For our last topic, topic 8, we're going to look at classifying equations, okay? So classifying anything is a way to just group things by some common feature. So if we're going to classify equations, we're going to classify equations based on their solution, okay? Now, up until this point, every equation that we've solved had just a single solution, and that is the norm. I'm not saying it's always the case. It is the norm for a linear equation in one variable. So for linear equations in one variable, you typically get just one solution, okay? However, there are two exceptions to that rule, okay? So it says here we can classify equations by the type of solution we can experience. So by type of solution. And there are basically three types of equations, okay? The first type of equation is called a conditional equation. Okay, these are the equations that have one solution. So for us, linear equations in one variable, one solution, a conditional equation. And you can kind of think of it as the condition on the equation is that it's true for this one value. Okay, so all equations so far have been conditional equations. Okay, solving results in x equals a or whatever your variable is, where a is some real number. Okay. So as you're going through the solving process, you're able to distribute, simplify, get all your variables on one side, constants on the other, and then at the end, you're finally going to be able to get a single value for the, or a single variable, a single x, a single y, a single z, and then that's going to equal some constant. That's how you know you have a conditional equation. You get a single variable equaling some real number, okay? Next up, we have a contradiction. Okay, so contradiction equations, I generally just call it a contradiction. So these equations have no solution at all. Okay, so when solving, the variables will cancel, leaving a false statement. Okay. All right. And when you get a contradiction, so again, the variables are going to cancel, leaving a statement that is not true, like 5 equals 7. That's certainly not true. And the way we would write our answer is we can write no solution. Okay, just write the words no solution. You can do squiggly brackets, but leave them empty. Or you can do this symbol. It's like a zero with like a diagonal slash through it. That's a mathematical symbol that means no solution. Okay? And then finally, we have identity equations. I'll generally just call it an identity. Okay? These equations have, believe it or not, infinitely many solutions. Okay? So like every real number on the planet is going to work. All right? So when solving, comma, variables will cancel, leaving a true statement. Okay, and the way we write the answer here is we would say x is all real numbers. So every decimal, every integer, every fraction would satisfy this equation. Okay, so from like on the surface, you can't tell which type of equation you're going to get. But once you get to solving, you can kind of tell if it's going to be a contradiction, an identity, or just one of our typical conditional equations. Okay, so let's go ahead and just practice. We're not going to practice a conditional equation because we've done loads of those in this worksheet. We're going to look at a contradiction and an identity, okay? Now, the directions here, notice for example 9, they say to classify and solve. So if directions say to just solve, we're just looking for the solution. Some number, no solution, x is all real numbers, okay? If the directions say classify and solve, we're looking for the words conditional equation, identity equation, contradiction equation, and then whatever the solution is. So be really careful here. It may feel a little nitpicky, but you do need to say both in this case. You need to state the type of equation and the solution, okay? So for part A, we have fractions. So right off the bat, we're going to get rid of the fractions. Remember, in my class, that's non-negotiable. I want you to clear your fractions, okay? So let's figure out what the LCD is. So I have denominators of 15 and 5. Since 5 will divide into 15 evenly, we're going to say the LCD is just 15. 15 will divide into itself, 5 will divide into 15. 15 is the LCD, okay? Now I'm going to take each term in my equation and I'm going to multiply it by the LCD of 15. So I get 15 times 4x minus 11 over 15 minus 15 times x over 5 equals 15 times x over 15 plus, don't forget, even if it doesn't look like a fraction, it gets multiplied by the LCD, plus 15 times 6. Okay? So now let's just clean things up. Let's clear out those fractions. So in the first term, I want to know how many times my denominator will divide into my LCD. 15 will divide into 15 one time. So I just get 1 times that numerator, and multiplying by 1 isn't going to do anything. So I just get my numerator. For the second term, 5 will go into 15 3 times. So I'm left with negative 3 times x. For the third term, 15 will go into 15 one time. So I'm just left with 1x. And then 15 times 6, I don't know off the top of my head. Was it 90? Whoops. I think it's 90, but let's double check. It's 90. Okay? So we do need to clean up the left-hand side a little bit. Notice I have 2 terms that contain variables. I want at most 1 term that contains a variable. Okay? So 4x minus 3x leaves me with just 1x. So I would get x minus 11. Whoops. Let me go back to the black marker. So I get x minus 11 equals x plus 90. Okay? Now, at this point in time, we have a single variable term and a single constant term on the left and the right. So we want to get all of our variables to the left. Okay? So this x that is on the right, I want to move it to the left. Since it is positive, think of it as plus x. The way we undo addition is subtraction. So x minus x, well, that's just 0, right? So on the left, x minus x is 0. 0 minus 11 is negative 11. On the right, x minus x is also 0. 0 plus 90 is 90. So all of our variables cancel, leaving a false statement. So when the variables cancel, leaving a false statement, this tells us that we have a contradiction. So that is the classification here. And that tells me that there is no solution. Now remember, you can write the words no solution. You can do empty curly braces, or you can do the little null set symbol, or you can just say no solution. I don't care which one. Okay, just make sure if you do the little curly braces, you leave them empty. Okay, that's the condition. You don't like merge these different ways to write the answer. There are 3 separate ways to write your answer. Okay, so this would be the final answer. We have a contradiction and there is no solution. Okay. For part B, we have this big old messy looking equation, but we're pretty good at solving equations at this point, so let's just get to it. Let's dive in, okay? First thing we want to do is distribute, and we do need to distribute twice, okay? I do want to remind you of something. If in front of a set of parentheses you just have a plus or you just have a minus, that would indicate that you're distributing positive or negative 1. So we don't write the 1, but please know it is there, okay? So let's clean things up. So on the left-hand side, I'm going to drop down my minus 4. Then I'm going to distribute my negative. So negative 1 times 11x is negative 11x. Negative 1 times 9 is negative 9. Drop down your plus 21 equals. And then I'm going to drop down 2 plus x. Then I'm going to distribute negative 1. So negative 1 times 12x is negative 12x. And negative 1 times negative 6 is plus 6. All right, so I've distributed, I got rid of parentheses, but now I've definitely got to do some cleaning up, okay? So looking at just the left-hand side for now, we have 2 terms. No, we don't. We have 1 term that contains an x, and then we have, let me double check, yeah. We have 1, 2, 3 terms that contain a variable. So let's start with the x. We're just going to write negative 11x. And then negative 4 minus 9 plus 21. If you want to, you can use your calculator. So I think we get 8 there. So negative 4 minus 9 is negative 13. Negative 13 plus 21 is 8. Okay, so negative 4 plus negative 9 plus 21 is 8. Always double check to make sure you don't make a goof, because sometimes I make goofs too. So we get plus 8 equals. And then on the right-hand side of the equation, we have 2 terms that contain variables. And then we have 2 terms that contain just constants, okay? So we want a single variable term and a single constant term. So let's start with the variables. I have 1x minus 12x. That's going to be negative 11x. And then I have 2 plus 6, which is 8. At this point, you can tell that you're going to have either a contradiction or an identity. So let me kind of highlight where you can tell. At this point over here, you could tell you were going to have a contradiction. And at this point right here, you can tell you're going to have an identity because the variables match exactly. And then the constants are either going to be the same or they're going to be different. Here, it doesn't matter what we plug in for x. On the left, we're going to multiply it by -11 and then add 8. On the right, we're going to take it, we're going to multiply it by -11 and add 8. You can plug in literally any real number and you're always going to get a true statement. Okay? Right here, you can tell that no matter what you plug in, you're going to get a false statement because we take some value and on the left we subtract 11, on the right we add 90. You're never going to get a true statement over here in part A. Okay, so part A, looking at where this arrow is, this is where you can tell you're never, ever, ever going to get a true statement. And then right here, this is where you can tell that no matter what you plug in, you're always going to get a true statement. But let's go ahead and take it all the way, okay? I like to go ahead and get to that point where I have either a true or a false statement. So I like to move my variables to the left. So I have this -11x on the right. I want to move it to the left. Since it's a -11x, we think of it as like -11x. So the opposite of subtraction would be addition. So I'm going to add 11x to both sides of the equation. Well, -11x plus 11x is just 0. 0 plus 8 is 8. Again, on the right, -11x plus 11x is 0. 0 plus 8 is 8. This is true. Okay, so the variables canceled, leaving a true statement. This tells me I have an identity. Let me write that a little better. This tells me I have an identity. And the solution is that x is all real numbers. No matter what real number we plug in, we'll get a true statement. Now, there is another symbol that means all real numbers. It is an R with like a double back. Okay. In math, you have lots of symbols. Math is kind of a language. In fact, when I went to UNCA and I was graduating, I was getting an associate in arts. And so I asked them, I was like, why on earth am I getting an associate in arts? Not an associate, a bachelor in arts and not a bachelor in science, because math is typically grouped with a science. And they said, oh, here, this was 20 years ago, but they're like, here we classify math with the languages, believe it or not. So this right here, an R with like a double back, that's a symbol that means real numbers. So if you were to use that instead of saying X is all real numbers, that is also fine. Just be careful with that. Okay, so there you have it, a contradiction and an identity. Conditional equations, remember every other equation that we have solved up to this point was a conditional equation. Okay, so that's the end of our worksheet. Very long worksheet. Thank you for sticking with it. This was a dense worksheet for sure. Okay, but this wraps up 6.2. In 6.3, we're going to look at problem solving with linear equations in one variable.